Hello friend, so today I am going to discuss on the topic of NMR spectroscopy of shielding and deshielding effect. So also this topic is very important for UG 6th semester student. So let us go to the topic. So NMR spectroscopy of shielding and NMR spectroscopy of shielding and deshieldings. Now, let us consider a molecule A, and we know that every molecule have atoms and every atoms have a nucleus. At the same way, this is another molecule which is let us consider this is a B, and this molecule also have atoms, and these atoms also have a nucleus. So I am repeating again, these are the two molecule A and molecule B, and there are different atoms. Every molecule have a atoms, and every atom have a nucleus, and nucleus is the positive charge, and uh, and around the nucleus there are cloud of electrons are present. There are cloud of electrons are also present. As we know that this nucleus, this positive charge, rotate on its own directions. This nucleus also have rotate in its own direction. That is, it rotate in its own axis. So, student, you know that when an molecule when a molecule, that is charged molecule, rotate in its own direction, that then it behaves like a magnet, and when it behaves like a magnet, there is generate an magnetic field. So this is the directions of the magnetic field, sorry, south to north. So in the second molecule, this positive charge rotate on its own axis, thus is generate a magnet, and this magnet behave like a magnetic field. So guys, if you observe that around the positive charge or around the nucleus there are dense number of electrons are present, that is the large numbers of electrons are present, as compared to molecule B, which is the less numbers of electron present in the molecule. So since the large numbers of electrons are present around the nucleus, thus in previous video I can discuss on this topic. Then if the inner shells contain large numbers of electrons, thus it is a highly shielded. So we can write that since the large numbers of electrons are present, that it is a highly shielding, sorry, highly shielding. And since there are negligible amount of electron present, thus their screening effect are less, thus it is highly deshielded. Deshielded. So guys, for easy understanding, shielded is called covering electron, and deshielded is called non-covering electron. So now suppose that these are the NMR chamber for the molecule A, and these two are also the NMR chambers of the molecule B. Suppose the NMR chambers have a magnet. So now this is the applied magnetic field. Now this is the applied magnetic field. So direction of the applied magnetic field by using the NMR machine. This is the direction of applied magnetic field. Sorry, by using NMR machine. So guys, हमने फिर से ये डिस्कस करके देता हूँ और अनदर लैंग्वेज में. Suppose दो मोल है, मोल A and मोल B. So each and every mole have a atom, and these atoms have a positive charge, and this positive charge, that is nucleus, rotate in its own axis. And if we know that we are know that if a positive charge rotate on its own axis, then it's create a magnetic field. And also around the nucleus there are many clouded electrons are present. Thus this positive charge is highly shielded as compared to this atom, because there are only two electrons are present. Thus in another language you can say that these electrons, these the covered electrons are called shielded, and these non-copper electrons are called deshielded. अगर हमने ये शील्डेड न्यूक्लियस को NMR चैम्बर में बैठाया तो क्या होगा? तो if we put this shielded nucleus or shielded atoms into the NMR chamber, thus we know that in NMR chamber they have a own magnet. They have a own magnet, and it's behave like a bar magnet. So if we applied a magnetic field, then the direction is south to the direction is that is south to north or north to south. And this for molecule A there are two NMR chamber considering, and this molecule B there also have a two NMR chamber. Now if we put this shielded nucleus into the NMR chamber, thus this applied, that is south to north direction, this applied magnetic field is the causes aligned to causes on its own directions of shielded nucleus. So ये क्या करेगा, ये जो shielded nucleus है, जब मैं NMR चैम्बर में ले आएंगे इसको, तो क्या करेगा, जो NMR चैम्बर का अप्लाइड मैग्नेटिक फील्ड है इसका साउथ और नॉर्थ डायरेक्शन में जाने के लिए फोर्स करेगा. बट द effect of external field on the shielded nucleus, this is the highly shielded nucleus atoms, is very less. Thus the shielded atom does not completely align. ये क्या करेगा, completely align नहीं होगा with the applied magnetic field. So if we draw, then this shielded nucleus is like that. This is shielded molecule. So guys, I am telling you again, then when we put this shielded nucleus into the NMR chambers, then the applied magnetic field will try this shielded nucleus into its own direction. That is this applied magnetic field direction is south to north, and also this applied magnetic field try to this magnet into its own direction, that is north, this north and this north in the same direction will try to the same direction, and this south is also try to this direction, same direction, but due to the highly shielding effect, this highly shielding effect, the external magnetic field of the shielding nucleus atoms is very less, thus the shielding atom does not completely align. सो हम ये बोल रहे हैं कि शील्डिंग इफेक्ट के कारण जो अप्लाइड मैग्नेटिक फील्ड है इसको इंटरप्ट करेगा और इंटरप्ट होने की बजाय ये पूरा अलाइन नहीं होगा. सो नाउ इफ वी अप्लाइड ए एनर्जी, if we apply energy, then what will be happen, that is applied energy is radio frequency energy, then the position of the nuclear shielded atoms will change, that is this north direction will change and it go to the south direction. We know that we also know that the opposite magnet always attract, that is this north direction attract this south direction and this south direction attract this north direction. So we can say that when it absorbs radio frequency, then this nucleus changes position, that is this position to this position, this is this. So this is the alpha, this is the alpha state, and when the change its position, then this state is called beta state. So when radio frequency is absorbed, this distance will cover or this distance will change. So when this nucleus is travel from this to this position, then it absorbs very low energy, and this will be happen in the shielding molecule. So if you consider this molecule, there are less numbers of electrons are present. So if we put this nucleus into this NMR chamber, then what will be happen, this applied magnetic field and the nucleus are completely aligned with each other because the shielding effect is very less. So we can put this way, that is north direction is north direction and south direction is south direction, but and this state is called alpha state. But when we applied an energy, that is radio frequency RF, then what will be happen, then this nucleus changes direction, that is in beta state, this nucleus change in direction, that is north south, north to south. That is in beta state we can say that the applied magnetic field directions and the nucleus magnetic field directions are opposite to each other. Now friend, if we compare these two, then you can say that this nucleus travel this direction to this direction, that is this direction to this direction. So it is travel to large direction, so it need to high amount of energy absorbed. So this due to the travel of large distance, it need to high amount of radio frequency. So this beta state This is called beta state, and this beta state need to high amount of energy. So in deshielding, they are need in beta state high amount of energy, and in the shielding we can conclude that they need lower amount of energy due to this reason, due to the shielding effect. And less low amount of energy is needed to align the direction to opposite to the applied magnetic field. So we can conclude that in a deshielded they are travel travel high distance, and in shielded they are travel into low distance. So if you conclude that in shielded nucleus they are travel low distance, that thus the lower energy is required, and in deshielded they are travel high distance, thus it need to high amount of energy. So if we represent this shielded and deshielded effect in the graphical representation, we can say that, suppose for shielded it need high amount of energy, but for deshielded it need to high amount of energy, and shielded it need to low amount. That is, this is compound A and this is compound B. So friends, for the overall process we can discuss with an example. So for better understand, we can take an example of the shielded and deshielded effect. We can take an example of organic compound like chloroethane, that is Cl CH2 CH3. We can represent this like that. So this chlorine is electron withdrawing group, and these two carbon compound which is an electron donating group. So this is an electron donating group, and this is an electron withdrawing group. So this is a compound. Let us consider this is a compound A and this is the compound B. Since it is attached with the electron withdrawing group, and this, so this is now CH2 is now shielded, not shielded, it is deshielded. Shielded atom. Also this group is an electron donating group, and this they donate electron to CH3. Thus CH3 is shielded atom. That is, if we represent this into the curve, we can plot in such a way, and we can show the peak in such a way, that is, for this peak is for which molecule? For shielded molecule. This peak is lower, that is CH3, and this peak is for CH2 molecule. So this is the whole process of NMR of shielding and deshielding effect with an example. So friend, this is the today's class, and please subscribe my channels and share with this video. So thank you guys. So for next time I will publish another new video.